Hello everyone, welcome back to Elefaantz YouTube channel. Today I'm going to be doing Are You Smarter Than an Engineer? I have 10 questions that were generated using an engineer question generator, and I'm going to try and answer them for you. So I have my bachelor's in computer science, and currently I'm getting my master's in engineering management. This is literally my last semester. I only have 2 classes left, so I'm excited about that. But yeah, I have 10 questions and I'm going to be showing you how I answer them on my iPad. So let's get into it. All right, let's get started with the first problem. This is the 3-switch problem. You're outside a room with 3 switches, one of which controls a light bulb inside. You can only enter once. Which switch controls the bulb? You can pause this and try to solve it yourself, but I'm gonna go ahead and solve this. This problem low-key reminds me of something that I've already dealt with. When I first moved into my new house, I didn't know which switch turned on which light in the living room, and there's like 4 of them. And I literally tried every switch. So we're kind of gonna use the same concept. So the 3 switches outside and the 1 switch inside the room. Just imagine that's a door. So we're gonna name this switch A, switch B, switch C. So like I said before, I'm gonna try every switch. So I'm gonna turn on switch A. I'm gonna turn on switch A first, then I'm gonna turn it back off. And then I'm gonna turn on switch B. And then I'm gonna leave switch B on. And I'm not gonna touch switch C. And I'm gonna go inside. And I'm gonna, turn the switch on. If the light turns on, I'll know that switch B is the answer. If it's not on, but it's warm, I'll know that switch A is the answer. If it's completely off, I'll know that switch C is the answer because this never turned on. So it has to be the one I didn't touch. All right, sounds good. All right, let's get to our second question. So this is a reverse engineer the problem. So you're given the output of a function for a set of inputs. Input 1, outputs 2. Input 2, outputs 4. Input 3, outputs 6. But input 4, outputs 10. What's the next output and what's broken? Immediately, I just start looking for a pattern. As a computer science person, that's what I do. And I noticed that 1 times 2 equals 2. And 2 times 2 equals 4. And 3 times 2 equals 6. So 4 times 2 should be 8. So this breaks the pattern. And the next one should be input 5 times 2. And that is the one that should output 10. This one was pretty simple. Okay, so we can move on to the third problem. The bridge riddle. 4 engineers need to cross a bridge at night. They share only 1 flashlight, and only 2 can cross at a time. This are their speeds. A, 1 minute. B, 2 minutes. C, 5 minutes. D is 10 minutes. When two cross at the same time, they go at a slower speed. What's the minimum for all to cross? So, immediately, I'm trying to see how many times I can use A. Because A has the slowest amount. So, I'm going to do A plus B first. So, that's going to equal 3 minutes. Then, A has to go back. So, that's another 1 minute. So, then let's just get C and D out the way. Let them cross because they take up the most time. So C plus D equals 15 minutes. And we're just going to let them stay there because they take up too much time. So I don't want them to cross anymore. But I'll let B go back because B is the shortest amount of time. It just makes more sense. So B will go back and that'll be an additional 2 minutes. And then A and B can come back again. And that's going to equal another 2 minutes. No, not 2 minutes. Sorry, 3 minutes. All right, so 3 plus 1 is 4, plus 15 is 19, plus 2, 21, plus 3, 24. Now it's time for question 4. Resource paradox. You have 1,000 units of fuel and a vehicle that uses 1 unit per mile, but you can drop fuel anywhere and pick it up later. What's the max distance you can travel before running out? So this one is kind of confusing, but remember, whenever you're traveling somewhere, you need to go and come back. So that's 2, right? 2 ways you can go, forward and backward. So what I would do is I would do 1,000 units divided by 2, and I'd get 500 units. And since I can go 1 unit per mile, the max distance I can go is 500 miles to make sure that I can actually go back to my destination. Nice and easy. All right, let's go to question 5. Build versus buy. You're designing a product. You can either build a feature in 10 days or buy it for $5,000 and integrate it in 1 day. Your team costs $800 a day in dev time. Which do you choose? So, this is kind of simple. What we'll do is we'll calculate how much it costs to build, and then we'll calculate how much it costs just to buy it. So, it'll take 10 days for us to build it, and it's $800 per day. So that is 800 times 10, right? And we get 8,000. So it'll be $8,000 for us to build it on our own. Okay? But it's $5,000 for us to get it and 1 day. So that would be $800 because it's $800 per day. So it would be 5,800. So the smarter choice is to just buy it. You have 2 identical clocks, and one loses 2 minutes a day. The other gains 2 minutes per day. How long will it take before they show the same time again? So, if one loses 2 minutes and one gains 2 minutes, the time difference is 4 minutes a day. And since there'll be 24 hours in a day, they will be, I'm just putting in my calculator, how many minutes in 24 days? 24 hours. 24 times 60. Put in my calculator. $1,440. And since it's 4 minutes apart, 1,440 divided by 4 equals 360. So it will take 360 days for it to show the same time. Or it'll show the same time every 360 days. Alrighty. So, 7. Infinite loop trap. Your code runs SCSS, copy, edit, for I in range 0, 1, 0.1, print I. What happens? Okay, this is very much what I do daily as a developer. This code is not gonna work because this is a 0.1. When we're doing for loops, we don't use float values. So you're gonna get like a huge error, and it'll probably be a type error because it needs to be an integer. So remember, if you're ever coding and you're using a for loop, you must use integers, aka whole numbers actually. All right, let's go to number 8, the box paradox. So you have a 10 by 10 box and an infinite supply of 1 by 1 cubes. You fill it completely. What's the hardest part of this task? So 10 by 10 by 10. That's 1,000. So 1,000 cubes can fit. And you have an infinite supply of cubes. So your problem is not the cubes. The problem is perfectly aligning the cubes. So this isn't really a math problem. Patience to do this, precision, and tolerance is the biggest part of this task. All right, next problem. Problem 9, elevator engineering. So, what I would do, well, let me read the problem first. Elevator engineering. You're designing an elevator in a 100-floor building. It can only stop once every 10 floors. How do you optimize passenger travel with this constraint? What I would do is I would make everybody take the other floor. I would have a huge sign that says, please take elevator 10. If you are on floors 1 through 10, that would just make it so much simpler. So then the elevator would only have to stop 10 times for each floor. So I would make a sign like this for 11 to 20, a sign like this for 21 to 30, a sign like this for 31 to 40, and so on and so on. I'm sure there are other ways to solve this because when you're doing engineering problems such as this, there's always more than one way to solve it. And this might not even be the best way, but this would optimize passenger travel. All right, number 10, the real engineer test. So you walk into a room and see a fan oscillating, a coffee mug on a heat plate, and a blinking red light. You can only fix one thing. What do you do first? And why? For me, the blinking red light. Because that would drive me insane. And you know, red lights are always trying to tell us that something is wrong. Like something might be on fire, there might be a malfunction anywhere, and red lights are critical to system failure. So that would be the first thing I would fix and why. So there's no math in this, but it's still something fun to solve. I want to say thank you so much for going through these questions with me and for watching my video. I enjoyed doing these questions with you so much. I know I'm not the smartest person in this world, but I hope some of my thinking skills can be applied to what you guys are doing every day. All right, and that's it for Elefaantz. See you next time.